Hi everyone, I am Dr. Kiran, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR IT, Hyderabad, India. Today, I give a talk on electronic device and circuits. So, the basic contents of the EDC subject are Unit 1, diodes. So, Unit 1 we are going to study the basics of diode, PN junction diode, and then Unit 2 consists of, we will discuss about diode applications. Diode applications means rectifiers, filters, etc. So coming to the Unit 3, we are going to discuss BJT. BJT means transistors, bipolar junction transistors. And then Unit 4 will be discussed FET, field effect transistors. And Unit 5 is about special purpose diodes like Jena diode, SCR, photodiode, solar cell, and so on. Okay, so all these modules will be covered in the continuous of this series of lecture series. Now, what are the requisites for this course? The main prerequisite for this course are engineering physics, and then you have to have minimum knowledge about engineering mathematics. So these are the important prerequisites for this course. So let us go to the overview of the today's talk. Today I am going to discuss about what is the importance of electronics and what is semiconductor, what is PN diode and its operating modes, and then conclude with summary. So let us start with the first topic, that is electronics. So electronics is a branch of scientific and engineering discipline, and we know without this electronics many applications cannot run. So for example, if you take a mobile phone, so can we imagine without mobile phone in our life, daily life? So it's a part of our daily life, so which can be achieved using this electronics. Okay, and then these electronics uses active devices such as transistor, diodes, and integrated circuits. Integrated circuit means combination of these transistors, diodes, and some passive elements. So passive elements means resistors, capacitors, and then inductors. Okay, so now these electronic devices have influenced very much in the development of many aspects of modern society, like you can say entertainment industry, healthcare industry, and then military, mobile communications, and also in security purpose, security reasons. So all these industries, these electronic devices play a major role. Okay, and then all these can be achieved with the help of these electronic devices. So first, all these can be done with the help of many electronic devices, and the basic point behind this electronics is electron. So the identification of electron in 1897 by J.J. Thomson. So from that, the electronic industry evolved a lot. So, and after that, after 50 years, 1947, transistors have been invented by John Biden and Walter. So this plays a major role in the electronic industry development. After invention of transistors, the electronic industry emerged like anything. Okay, so this is about overview of electronics. What is the importance of electronics? Now let us see what is the basic of electronics. So electronics means particularly we can play the play with electrons. Okay, so these electrons, the electronic devices can be fabricated with the electronic chip, so with a semiconductor material. Now it has an electrical conductivity value falling between that of a conductor such as copper and an insulator and such as a glass. Okay, so conductor means such as copper and insulator means glass. So the electrical conductivity of a semiconducting material, which is very much used in the fabrication of electronic devices. So this semiconductor has some electrical conductivity whose value lies between those of conductor and insulator. Okay, of course conductor has more electrical property and insulator is very less. So in between you have the semiconductor has the electrical conductivity between these two. And now in a process called doping, small amounts of impurities are added to these pure elements. So here doping is in a process which is used to vary or change the properties of a semiconductor. So the process is called what? Adding some impurity to the pure semiconducting material. So impurities we can add to the pure elements, pure semiconducting elements, causing large changes in the conductivity of the material. So why we need to go for doping? Doping is to change the electrical characteristics of a particular semiconducting material. So the basic raw material for silicon, for example, silicon is the best semiconducting material. So it available 25.7% on earth crust. So most abundant. See, generally germanium also is one of the important semiconducting material, but is less abundant and more cost also. So most of the applications silicons have been used. Okay, and other material or conductors. Conductors are example for the conductors are metals and insulators are wood. Okay, so let us see other information about this semiconductor. So here the semiconductor, how we can utilize the semiconductor. So if a trivalent impurity atom, that is like aluminum, boron, indium, gallium, etc. So if you mix this trivalent impurity with a pure tetravalent germanium or silicon crystal, then p-type is formed. So this is about a generation of p-n semiconducting materials. So p-type is generated by adding tetravalent impurity atom like aluminum, boron, indium, gallium, etc. to the pure tetravalent germanium or silicon. Similarly, if a pentavalent impurity atom, so pentavalent impurity atom, phosphorus, arsenic, stevia, bismuth, etc. is mixed with a pure tetravalent germanium or silicon crystal, then p-type is generated. So pentavalent. So more than penta means 5 in outermost orbit. Okay, 5 electrons will be present in the outermost orbit. So therefore it is pentavalent. Similarly, trivalent. So only 3 electrons will be available at the outermost. So this trivalent means less number of electrons are there. So it is donor atom. So excuse me, it is acceptor atom, and whereas it is donor atom. So it has more number of electrons. It can donate. Similarly, trivalent, less number of atoms, so it can accept one atom. So all these can be the generation of semiconductor p-n diode. So here you can observe the figure, p-n junction diode. So p-type material and n-type material, and in between if you add these two p-type and n-type material, so there is a depletion region, so which opposes the further flow of electrons to flow from one side to another side. Okay, so this is the practical diode symbol. Okay, this is anode and this is cathode. This is minus and this is plus. Okay, so this round circle will represents minus. Okay, excuse me. Say anode and this is anode and this is cathode, minus plus. Okay, so this is the how we can generate the PN junction diode. Okay, now let us discuss the other information about diffusion and drift. So before going in detail about the PN junction characteristics, so we have to know about the diffusion. So what is diffusion? Diffusion means if a few free electrons are added to a p-type semiconductor, for example, so this is a p-type semiconductor which has more number of holes on one side and less number of holes on another side. Okay, and now these holes are bombarded or collide with the other side, then they use it to repel because both are positive and positive charged, similar charges, like charges repel we know. So therefore due to this they repel or they move towards the lower concentration. Okay, so for example this is the concentration, majority charge carrier concentration, so will move like this. Okay, so that is there is a gradient, charge carrier gradient will be present in the material, p-type material. So this is called the movement of electrons due to this diffusion is called diffusion current. Okay, so this is the redistribute themselves so that the concentration will be more uniform. So actually this diffusion current is observed in non-uniform material, like the distribution will be non-uniform. Okay, then drift. What do you mean by drift? Drift means applying an external electric field across the semiconductor will cause holes and free electrons to drift through the crystal. That means let us say this is one PN diode. Okay, for example, so if you apply positive supply to the p type and n, so p is connected to positive of the battery, n is connected to negative of the battery. In such case what happens, these holes are repelled by this positive terminal and these are travel towards this. Okay, so in such case some of the electrons or holes may collide, bombard with the other atoms in the crystal PN diode or in the connecting wires. Okay, so due to that what happens, so for example this is one atom, so they bombard with this atom, so in such case they move random direction, they move in random direction. So this movement of random direction will cause the drift current. So for drift current we require some additional voltage, whereas in diffusion we don't require any additional voltage. Okay, so this is about your drift and diffusion. Next topic is operating modes of PN diode. So with the knowledge what we have studied so far, so with that knowledge we can able to analyze operating modes of PN diode. So unbiased PN diode. So biasing means what? So biasing means adding external voltage to the PN diode. So here unbiased PN diode means what happens? So in this case the depletion width usually more. The depletion width will be more because there is no movement of electrons from one side to another side, and in this depletion mode there is a immobile ions. There will be immobile ions. Okay, so these are free electrons and these are the empty holes. Okay, they stable. So diffusion, we can expect diffusion current in this. So if you dope with a different concentration, so depending on the different concentration, so the electrons move from high concentration to low concentration like this. Okay, this is about unbiased PN junction. Now forward bias PN junction. So what do you mean by forward bias PN junction? So if p type material, so p is connected to positive of the battery and n is connected to negative of the battery. In such case what happens? these holes are positively charged. These are positively charged and connected to positive. So in such case, positive positive means these positive terminal will repel these holes and they will move towards this. Similarly, these electrons also repelled by this negative. These electrons again repelled by this negative, and these are repelled like this and cross the junction and enter into the P side. Okay, so this constitutes the current. So in forward bias condition, there will be some current flowing through the diode. So in reverse bias, what do you mean by reverse bias? So in contrast to the forward bias, in this case, P side is connected to the negative of the battery and N side is connected to the positive of the battery. So in this case, the holes, positive holes are attracted towards these are attracted towards the negative terminal of the battery, and negative charged electrons are attracted towards the positive of the battery. In such case, this depletion width will be increased because these are attracted towards this, these are attracted towards this. So the depletion width will be increased. So therefore the potential barrier also increases, VB also increases. So in order to make current conduct in this reverse bias direction, we require some more amount of voltage, some more amount of voltage we required. Some mechanism is there that we will discuss in the later classes. So this is about a reverse bias condition. Now forward bias and reverse bias characteristics, how they behave in the PN diode. So forward bias and reverse bias characteristics are given like this. So on x-axis we will consider voltage, applied voltage, and y-axis we will consider current. So in forward bias condition, what happens? The moment you apply the voltage, input voltage, the diode does not start conduct. Okay, the diode does not conduct initially, but at a particular voltage, that is cut-in voltage, the diode starts conducting. What is cut-in voltage here? The voltage from which the diode starts conducting is called cut-in voltage or knee voltage or reference voltage. So why? Because it has to, we know that in PN diode we have a potential barrier voltage. So this voltage must be, the applied voltage, that is V, must be exceed this potential barrier voltage. So this potential barrier voltage varies for material to material. So for example, this VB is equal to 0.3 volts for germanium and 0.7 volts for silicon. Okay, so this is nothing but cut-in voltage. So because it has to, whatever the electrons and holes in the immobile ions, they have to recollect, they have to reback again. So that requires some more energy, some more time, and some voltage is required. So that voltage is this one, cut-in voltage. So it varies with respect to the material. So therefore this applied voltage must be exceed this VB, then only current starts conducting. So in the reverse bias, what happens? In the reverse bias condition, so ideally there will be no current flow through the diode. Initially it is 0, but still there is a current, minute current of the order of microamperes in reverse bias. So that current is called reverse saturation current. Reverse saturation current due to minority charge carriers. Minority charge carriers. Okay, so that's all about today's talk, and let us conclude the session. So what we have studied today? So what is the importance of electronics? So electronics plays a major role in our daily life, and then we have discussed semiconductors. These are the primary elements of any electronic device. And then PN diode is an electronic device which is which is the primary element, primary component in any electronic device or any integrated circuit. So drift and diffusion currents. We have studied what is drift and diffusion current. So drift current is required drift current required applied voltage, and this is not required. Okay. Operating modes of the PN diode. So forward bias we have discussed, and then reverse bias, and then its characteristics. Okay. So the next topic will be on resistance and current components of the PN junction diode. Thank you.